Hello champions, welcome to my math class. Today I'm going to talk about laws of integers, but now I'm going to add something that deals with linear programming. So what's linear programming? So in linear programming, we're going to incorporate the comparisons of numbers using the knowledge of algebra in it. For example, maybe we're going to find the values that satisfy a specific linear expression. So in which way? Let's say before knowing about linear expression, we need to know how we can compare things. Either which one is bigger than, which one is smaller than, understanding the crocodile clips, and knowing which symbols represent what. So basically, I'm going to start by introduction. When we have this, when we have my left hand like this. What do I mean? If I have my left hand like this, I'm making something like a V. If I'm making something like a V, this means is a symbol that means less than. And then if I have this pointing the other side, my right hand side making a V, what do I mean? This one means greater than, or you can say larger than. This was less than or smaller than. Then if I have this symbol, two double line, this means equal. Like here, magnitude is the same. Like for example, 2 is equal to 2. Magnitude is the same. 2 is equal to 2. Magnitude is the same. What if I have this now? This is called less than or equal to. Less than or equal to. What does this mean? Greater than or equal to. Greater than or equal to. Now, how do I incorporate these symbols now in understanding comparison? For example, I want, if you're doing a core math, maybe you need to understand what is less than, greater than. I'll go by comparing now numbers. Now, let's say, for example, we say 2 dash 3. If you compare between 2 and 3, which one is bigger? Say 2 is smaller. So you start reading from your left, going to the right. So you say 2 is less than 3. If I'm talking about 5 and 3 here, I'll say 5 is greater than 3. I use my right hand. 5 is greater than 3. So here say 5 is greater than 3. That's what you write there. Then here, so 5 is greater than 3 or bigger than 3. If you have 129 dash 10, obviously say it's greater than 129 is greater than 10. But if I'm using now, let's say 10 dash 129, I'll say 10 is less. I'm using my left hand. 10 is less than 129. All right. Now, if I go down, I need to show something is less than or equal to. For example, let's say you say 3 is less than or equal to. 3 is less than, maybe if you want to show something that is less than or equal to, values or numbers that are less than or equal to. For example, you can say 3 is less than or equal to let's say 7. This means the solution here, 3 can be less than or equal to 7. So it means in this inequality, when you're comparing these two numbers, so 3 is less than, yes, but it's also part of the equation. Are you together? So even 3 can be the solution. Sometimes you might have say 3 is equal to 3. This means these ones are equal. These ones are equal. 2 is equal to 2. These ones are equal. Now, how do we use this when you're talking about now inequality? Maybe we need to find the values of x that satisfy a specific linear inequality. Now, how do we apply this in linear equality? So in linear in linear inequality, here we're going to understand this. We are going to incorporate this with the knowledge of a number line. For example, let's say we say x is greater than 5. How do you show this in a number line? Now, to show this in a number line, to represent this in a number line, to represent x is greater than 5 in a number line is always covered in a different scenario. In this case, mostly tested, it's always like, okay, if x is greater than 5, what are we supposed to know? Number one thing, we need to know that when we represent number line, we can either use full bolded, this is full bolded, or open to show an integer. Okay, for example, x is greater than 5. So if you see something like x is greater than 5, this means the value of x is all numbers, whole numbers above 5, which means 5 is not included. 5 is not part of your solution in this case. 5 is not included. In that case, if I have a number line, this means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as you go on to positive infinity. That means if I'm supposed to represent, I'll use this as an open and then draw an arrow to show that all the numbers above, apart from 5. So it can be either 6, 7, 8, 9 to infinity, apart from 5. That's it. So if we say x is less than 2, what does it mean? X is less than 2. If I say x is less than 2, that means I'll draw my number line there and say 0, 1, 2, 3, 4, 5, 6. And then negative 1, negative 2, negative 3, negative 4. And then I have this case and they say, so x is less than 2. So we say all values of x that are less than 2. And 2 is not included. It can be all the numbers apart from 2 to negative infinity. So you can say there 1, 0, negative 1, 2, negative infinity. Wow, that's it. What if it's you say x is less than or equal to 3? Correct. How do we show this in a number line? You draw a number line. Wow, this is highly tested in IGCSE exam. You come to where we have 0, 1, 2, 3, 4, 5, 6. Then negative 1, negative 2, negative 3. So where there is 3, we say x is less than or equal to 3. So this less than or equal to 3 is full bolded because that 3 is also part of our answer. So we say anything less than 3. So we say it can be, so this means 3 is part of the solution. 3 is part of our solution. 3 is part of our solution. So it means it can be 3. It can be 3, 2, 0, negative 1, 2 to negative infinity. So also 3 is part of our solution. That's how you represent. You represent it with a full bolded. Now, what if you say x? What if you say x is greater than? We say x is greater than or equal to to 5. How do we represent this in a number line? Now we start from, let's say, 0, 1, 2, 3, 4, 5, 6, 7, as we go on, 8, 9, 10, to positive infinity. And then we have -1, -2, -3, -4, as we go on. So in this case, in this scenario, what do you do? In this scenario, we understand that x is greater than 5. So you go to where 5 is, or equal to, so it means full bolted. Greater than 5 or equal to, it's full bolted. Then you go up. Full bolted means 5 is also 5 is part of 5 is part of the solution. So it can be 5, 6, 7, 8, 9, etc. to positive infinity. That's it. Wow. This is very, very important. Now, what happens when it's now given in range? Let's say, for example, we say -2 is less than x, and x is less than or equal to 6. -2 is less than x, and x is less than or equal to 6. This is how do you represent this in a number line? How do you represent this in a number line? Or, for example, we are told to mention the integer values that satisfy the inequality given here. So what you'll do, you draw a number line. Let's say if you have to represent this in a number line, how do you do? You draw a number line from -2. Let's say -2, -1, 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then x, so x is -2. So we say -2 is less than x, so it's not included. You do that. It's not included. It goes, and then x is less than or equal to 6. So something less than or equal to 6 is full bolted. 6 is also part of the solution. Therefore, you draw to where you have. So then, if you are to mention, you have to mention the integer values of x. So mention the integer values of x that satisfy the inequality above. So you will obviously say -1, because -2 is not included. So -2 is not included in solution of x, but 6 is included. Correct. So -2, you say -1, 0, 1, 2, 3, 4, 5, and 6, because it's included. So these are the integers that satisfy the inequality. This is how you need to understand when you are asked in your IGCSE exam question. So for example, you might be asked, write down the integer values of x. So example 1, write down the integer values of x. Write down the integer values of x that satisfy the inequality -2 is less than or equal to x, and x is less than 2. What do we do in this case? Obviously, we know -2 is part of the solution, but 2 is not part of the solution. Therefore, -2 is part of the solution. So -2, -1, 0, 1, 2, 2 is not. So these are the values. So it's -2, -1, 0, 1. This is how these kind of questions might be tested, and they want you to understand, to know what to do. Yeah, like showing deeper understanding of negative number and positive number. In this case, they will basically want you to do. And that will mark the end of this unit. Thank you for joining.